An algorithm is a step-by-step procedure that takes a problem and returns a solution. The problem itself is defined by parameters. Assigning specific values to the parameters produces an instance of the problem. For example, consider the problem of putting a list of numbers in order. The solution is the list of numbers in order. The parameters are the specific numbers to be sorted, and one particular instance might be to sort the numbers. An important question: how long will it take to solve the problem? To answer that, we can, for now, write a metacode program to solve the problem. Then, for now, count the number of times each line must run to complete the program. For example, say we want to sort the list. Now, a human might sort the list as follows. Find the smallest number in the list, which is 4. Find the second smallest number in the list, which is 8. Then lather, rinse, repeat. So can we write this in metacode? So suppose we're trying to sort a list with n items, a1 through an. How could we find the smallest number on the list? A human approach might be the following. Take the first number on the list, then every time you encounter a smaller number, swap it out, and lather, rinse, repeat. So how many steps will this take? Suppose we take A1. We'll have to compare it to A2, A3, and so on up to AN. And this requires n minus 1 steps and will return the smallest number in the list. Now our list has been modified, so now we only have n minus 1 entries. So we'll take the first entry of our modified list and compare it to the remaining n minus 2 numbers, and this will give us the smallest number of the remaining list. And we need to continue this until our list only has 2 items. We'll then need one last comparison. So in total, we'll need to take n minus 1 plus n minus 2 plus n minus 3 and so on down to 2 plus 1 steps. If we rewrite this as, it becomes an arithmetic sequence with first term 1, last term n minus 1, and n minus 1 terms, so its sum will be. And so this method requires n times n minus 1 halves steps. Notice that the number of steps required is a function of n, the number of entries in the list. We call n the input size, and expect that, in general, the number of steps required for an algorithm is some function of the input size. Let's consider a different sorting algorithm. As before, we'll take our first entry A1 and set it down as our first entry in our sorted list. Next, we'll take A2. If A2 is less than A1, we'll put it down before, otherwise we'll put it down after. This gives us 2 entries in our sorted list. Now consider the next entry. It might be less than our first entry, and if it is, we know it has to be less than the second. So we don't need to make any further comparisons, we can place it immediately. But if it's not less than S1 prime, we'll need to compare it to S2 prime. So the question is, does placing the third element require 1 or 2 steps? It might require 1, but we can't guarantee it. So it's useful to remember, nobody ever complained when a job was completed ahead of schedule. While it's possible we could complete the sort on fewer comparisons, we can't guarantee it will happen. So instead, we'll assume the worst case scenario where we'd have to compare every entry to every sorted entry. And this means placing A2 will require 1 comparison to the first entry in our list. Placing A3 will require 2 comparisons to the 2 entries in our list. Placing A4 will require 3 comparisons to the 3 entries in our list, and so on until we get to the n, which will require n minus 1 comparisons. So in the worst case scenario, this sort will require